Thanks to space telescopes like the International Hubble mission, we know there are some 2 trillion galaxies in the observable universe, and hundreds of billions of stars in our galaxy alone. Now technology is revealing planets orbiting many of these stars, and we're beginning to understand what they're like. In 1995, Michael Meyer and Didier Queloz from the Geneva Observatory co-discovered the first ever exoplanet orbiting a Sun-like star. This year, they won the Nobel Prize in Physics for their work.
In these days, I was using a technique that we call radial velocity, which is observing a star and looking for any change of speed in the star. Well, since then, the field has just exploded. As you may know, there is really now thousands of exoplanets. There are a lot of planets known to be transiting, which means the planet goes right in front of the star. And that's these techniques that we're using for the Cheops mission.
Thanks to ground-based observations and planet-hunting missions such as COROT and Kepler, more than 4,000 exoplanets have now been discovered. They range from small rocky planets to gas giants larger than Jupiter. Cheops will be targeting known planets between the size of Earth and the icy giant Neptune, which has 4 times our planet's radius. The mission will probe the nature of these exoplanets and begin to answer questions such as whether any of these alien worlds could support life.
Cheops' aim is to measure the size of already known exoplanets. So it's not a discovery mission. It is really aimed at precisely measure the size. And once we have the size and possibly the mass, we can derive the mean density, and from then we know a little bit what the planet is made of.
Data from the orbiting space telescope will be processed in banks of computers at the Geneva Observatory, home to the Cheops Science Operations Centre, where scientists will also decide which exoplanets to target.
We're sending the observation program to the Mission Operations Center in Madrid, where then the information is uplinked to the actual instrument. The instrument is configured to observe the star, and then the telemetry, the data is downlinked to the Mission Operations Center and right away forwarded to us here in Geneva, where we then can do the data processing, archive the data, and then provide it to the scientists all over Europe and to the world.
By making repeated observations of several hundred planets, Cheops will provide an important insight into the inner structure of exoplanets, how they form and evolve, and whether any are even a little bit like the Earth.